This is our video for section 1.5, kind of an introduction to angles. And if we look at our image on the right, this is going to be our example angle. Notice we just have the vertex labeled as A. We have our sides, and on each of these sides we have a couple of points B and point C. So we can think of an angle as a set of two different rays. And we see that here. So from point A, we have like one ray, AC, and then another ray, AB, coming here and here. And those rays, when they make up the angle, they have the same endpoint. We can name rays in three different ways, and it's going to kind of depend on what you're given as to which naming system you want to use or can use. The first way that we can name an angle is using its vertex. So in this case, we can call this just angle A. And our symbol for angle looks like this. So it's kind of like a crooked L, or really just like a small 45-degree-ish angle. And we can call this angle A. We do need to be careful, though. We'll see an example in a minute where it would not be appropriate to just use angle A. If there is more than one angle coming from this vertex, we can't use this naming method because it would be ambiguous. We wouldn't know which angle we were talking about. So we'll see an example of that in just a second. The second way that we can name a ray, this is probably the most common. So a point on each ray and its vertex. I think I just said name a ray, where I mean ways that we can name an angle. The important thing here is that the vertex has to be the middle letter. So the order matters in this. So I kind of think of, if I trace the angle, I could call this angle CAB, or angle BAC. So that vertex always has to be the middle letter. So again, CAB or angle BAC. And finally, if there is a number, we can use that. So that number will be small. It'll be right in the corner inside of the angle. And if there is a number there, we can use that to name our angle. So this could also be called angle 1. The diagram on the right just shows interior versus exterior. So when I say like naming by a number, that will be on the interior of the angle. Generally speaking, that's what we're talking about when we refer to angles as the interior, but we can technically think about the exterior. Right? This has a degree measure as well, that we may get into it a little bit later time. This is a place where I would pause and try to name 3 angles in this example, and then unpause and come back and look at the answers. So this is that case I was talking about a second ago, where we could not just call any of these angles angle M, because notice there are 3. I have this angle here, the other small one, and then the full angle as well. So if I just said angle M, I wouldn't be sure which one I was talking about. And there are also no numbers, which would be here and here if they were there. So we have to use that method too. I was expecting that you guys would kind of write it over here, but just for example's sake, I'm going to just write above here. So our first angle, I'm going to call this my first angle here. So we could call this angle JMK, or angle KMJ, as long as M is that middle letter, because it is the vertex. The second angle, I'll look at the other small one next. So we could call this KML, angle KML, and then our third angle represented here is the bigger one that kind of contains the smaller 2. So, and we would call that angle JML or LMJ. Either one is fine. So 3 different angles here. We could name each of them in 2 different ways. Moving on, types of angle. You will want to know these references. Many of us are familiar with them already. An acute angle is any angle that is greater than 0 and less than 90. As soon as we hit 90, we become a right angle, and we need to be really careful with these. A lot of students see angles that look like this, meaning they see something like this, and they just automatically assume that it is a right angle. Unless there is that box in the corner, and if it's a color diagram, it's almost always red. Unless that box is there, we do not know for sure that it's 90. So do not assume that angles are 90 degrees unless you either solve an equation, like proving that it's 90, or you have that box in the corner. Next is obtuse. This is an angle greater than 90 degrees but less than 180. And then finally we have a straight angle. So if you think of this as a vertex and we kind of, maybe it started here and we just completely unfolded it till it was a flat line, we call this a straight angle. And you see this a lot in problems where there'll be another line like this or something, and you have two pieces, and you need to know that those two pieces add up to 180 because they make a straight line. So that does come into play in a lot of our problems. Moving on here, reading a protractor. So this is a protractor, and there are a lot of different angles drawn on it, or a lot of lines drawn on it, I guess, just for reference. So we could think of, for example, we could think of this as an angle, and we could take a reading. So angle JHK is what this would be. And a couple important things when you use a protractor. So let's just think about that angle JHK. So I'll kind of draw this in red. So I know maybe my lines aren't perfect, but just assume that these are right where the blue are. So if I'm just thinking about this angle alone, it's important when we line up our protractor, there's always going to be a dot or a circle. It's often an open circle, so you could put your pencil through there and actually put a dot right there to help you like make an angle, or just to help you see the vertex better. So that vertex should always be right in the center of that dot, and then one side of your angle, it doesn't matter which side, should be lined up with, notice here there's there's a black line that runs right through that circle, and that's your 0 line. All right, so one side of your angle should be lined up with that, and then the other side of the angle gives you your reading. And if the line that you're working with is too short, just take a ruler or some sort of straight edge and extend that line long enough until it reaches the numbers on your protractor, because you have to be able to read the numbers. You can't just guess. So this angle, we've got it all lined up properly. Notice that we've got two sets of numbers, so we need to decide which set is correct. Are we using the 50 and 60, meaning that this line would be 55 degrees because it's halfway between 50 and 60, or is this line 125 degrees because we're between 120 and 130? And notice the protractor is this way because if the angle were flipped, we could have the angle over here as well, and we still need to be able to get a reading. So it goes from 0 to 180 this direction, and then same way in the other direction. And the answer is we just kind of need to think a little bit about what angle do we have and use some common sense. So is our angle greater than 90 or less than 90? All right, is it acute or obtuse? In this case, it is acute. This is less than 90 degrees. Remember, 90 is like the full L, and any angle smaller than that is acute, and any angle larger than that is obtuse. So since this is an acute angle, we want to use the smaller numbers. There's no way this can be greater than 90 degrees, so this would be a 55-degree angle. So what I would recommend, again, take a look at these and see if you can determine the correct measurements, and then come back for the answers. So before I sent you off to do that on your own, we didn't talk about this notation at all. This M here just means the measure, right? So if I'm reading this, statement, I'm reading it as the measure of angle GHK. That's what I'm reading. So if it helps you to make a little note that this M means measure, go ahead and do that. That tells me that I'm looking for a number specifically. I'm not just talking about the angle itself. And we've seen similar notation with segments and things as well. So back to the problem. GHK would look like, I'm just going to kind of trace it roughly here, look like this. This is an obtuse angle. And so that's actually through that same mark we were looking at before. This would be the 125. Okay, so this is our 125. And notice, if I combine that with that other one, JHK, that 55, they make a straight line. We're going to come to call that a linear pair of angles. Right, so JHK is the 55, and then GHK is the 125. Next, we've got the measure of angle JHL. So J to H to L, that's straight up 90 degrees. So I guess I could be writing here, this is 90 degrees, this was 125. And then LHK, this is the one that gets a little bit interesting. So here to here. All right, so if we need to figure out this space here, now we're not lined up like we said we need to be on this line. You could, if you had another protractor, you could line it up so that the base of your protractor was on this line and your open circle was on the vertex, and you could get a measurement here, and you would get 35 degrees. We can also find that just by finding this space. You could count, right, from 90 to 100, 110, 125, and get 35 that way. The easiest and most common way is probably to just subtract. So we can use either set of numbers. I can use the upper set of numbers and do 120 minus 90. So 120 minus 90, sorry, 125, my mistake. 125 minus 90 is 35 degrees, or the smaller numbers. So 55, let's do it the larger minus smaller, 90 minus 55 is also 35 degrees. So even if you're not lined up properly, if you're given a diagram like this, just find the difference between those two numbers and you're good. Most of the problems that we see are going to be very similar to this next one. So on the left is kind of a diagram of the general idea. So this tells us if I've got some big angle like this, so RST, which is split into two smaller angles, so I've got an angle here. The two smaller angles, since they're connected and together form this large one, if I add up the two smaller ones, they equal the large. And so that's going to allow us to set up an equation, and in the case of our example, solve for x, and then eventually find the measures of those smaller angles. So it tells us that the measure of LKN is 145. So this is LKN. So the entire thing is 145. And it wants us to find both of the smaller angles. So this angle over here and this angle over here. And what I know is, like we just said, this angle plus this angle have to add up to the whole, which is 145. So my equation is 2x plus 10 plus 4x minus 3 equals 145. Technically, since these are just added together, I don't really need those parentheses. I just use that to show that they're separate angles that I'm adding together. So we could rewrite this without the parentheses. 4x minus 3 equals 145. And the first thing we want to do here is to just combine like terms, meaning I've got some x terms. These are both x terms. They're both positive. If I combine those together, I have 4x and 2x. That gives me a total of 6x. And I also have a positive 10, and then we have a minus 3 over there on the right. So 10 minus 3 is positive 7. And this is still equal to 145. So when you have a lot of terms over here, and some of them can be combined. That's always going to be your first step. All right, let's simplify by just combining the x terms, combining the numbers, and then go from there, because this looks like something that we've seen a lot already this year. And this is just a quick two-step equation. I'm going to subtract 7 from both sides. That leaves me with 6x equals 138. And then when we divide by 6 on both sides, we find that x equals 23. But we're not done, because remember, we wanted to find the measures of these two angles. So since I know x is 23, now I can just substitute that in here. So instead of 2x, I can just write 2 times 23, because x is 23, plus 10. 2 times 23 is 46, plus 10 is 56 degrees. Now for the right side, we could do a couple things. We could plug x in again, because we have that expression that represents the right angle, or we could do a little subtraction, because the entire thing is 145, and so if I just subtract 56, that should give me whatever is left. We'll get the same thing either way, it doesn't matter. I'll just show the substitution. 4 times 23 minus 3. 4 times 23 is 92, minus 3 is 89 degrees. And this is, again, one of those cases where it looks like a 90 degree, but we cannot assume that. Anytime you've got numbers, if it gives you numbers to solve for an angle, you have to use those numbers. You can't just use a protractor or guess, right? Use the numbers that it gives you. Final example is giving us kind of a word situation and asking us to find a missing angle. So whenever you have this and you don't have a diagram, your best bet is going to be to make a diagram. And when you do, you don't have to worry about it being perfect. You know, your degrees of your angles don't have to be perfect. We're more just trying to get a sense of what this is going to look like. So as we read through, it tells us that ray QS bisects this angle, PQR, and then it gives us the measure of one of those angles and asks us to find the measure of another angle. So let's first just set up our diagram. If this is a bisector, remember that means that it cuts our angle perfectly in half. And so let's start with the angle that I'm bisecting, PQR. So I'm going to start with that, and I'm just going to make an angle with enough room to bisect. Put some points on here, P, Q, R. And then this tells me that QS is my bisector, so I'm going to just make this as close as I can. Put that point Q up here somewhere. Whoops, I'm sorry, not Q. That's point S. Point S goes here. And then we can start finding some numbers. So we've got the measure of PQS is 24, so PQS is 24. Let's put that in there, 24 degrees. And now the thing that we need to take away from this is, since QS is a bisector, that means it cuts the angle perfectly in half. Therefore, this other angle, SQR, must also be 24 degrees. There is a little notation we use to show that angles are congruent. We use little arcs across the angle. And so if those both had like one arc, that would tell us that they were the same. Even if we didn't have numbers in there, that would be an indication. Sometimes they will use double marks, and that would mean that any angles with the double mark are also congruent to each other. So to finally answer the question, it says find PQR. PQR is the total. And again, the two smaller angles added together equals the whole. So the measure of angle PQR is equal to 24 plus 24, which is 48 degrees.